Okay, hopefully everybody's logging in now. I just wanted to say good afternoon to everybody and welcome to today's webinar, IBM Power 11 Migration Masterclass. My name is Iqbal Khan and I'll be your host for today's session. I am the managing partner at FAM Technology Partners. And before we dive in, and we're thrilled to have you join us. And before we dive in, let me briefly introduce myself and the company FAM Technology Partners. I am a business leader with over 25 years of experience leading successful IT business technology and retail technology businesses across different sectors. I've had the privilege of serving on many boards, and I am thrilled to be your host today. At FAM Technology Partners, we specialize in enterprise infrastructure solutions with a particular focus on IBM Power Systems, AIX, IBM I, Flash Systems, and all related technologies. As an IBM Gold Business Partner, we're committed to helping organizations maximize the value of their IBM investments. Today's focus on Power 11 migration represents a critical opportunity for businesses to modernize their infrastructure, enhance performance, and prepare for the future AI-enabled workloads. Our partnership with IBM allows us to bring you expert insights and practical guidance on navigating these complex migrations successfully. Before we begin, let me quickly cover a few housekeeping items. Today's webinar will run approximately 60 minutes, including a time for Q&A at the end. All attendees are muted to ensure a smooth presentation. And in terms of questions, please use the Q&A feature at the bottom of your screen to submit questions throughout the session. We'll address as many as possible that we can during our Q&A segment towards the end of the webinar. If there are any questions beyond that, we will provide an email address or a link for you to be able to submit those through. Feel free to use the chat to network with other attendees or share relevant comments that you might think are applicable. The session is being recorded, and a recording link will be shared within 48 hours after the webinar's completion. If you experience any technical difficulties, please try refreshing your browser or rejoining the session, and somebody will let you in. Today, we have two exceptional speakers, and we're really excited about having them on and discussing this topic. Firstly, one of our own, Bruce Turgeon, who is a specialist with 35 years at IBM with IBM experience, recognized as a power systems top gun guru and a subject matter expert. Bruce specializes in IBM Power, AIX Linux, relational databases, IBM I storage, and quantum computing. He holds an honors physics degree from the University of Waterloo and an IBM certified architect, with multiple IBM awards, including Best of the Best, Golden Circle, Best Defender, and Thought Leader. Really excited to have Bruce talking to you about some of the things that he'll be mentioning around Power 11 and the migration to it. Secondly, a person that comes with a lot of credibility and a lot of credentials, Arnold Ness, who's IBM's Canada's National Hybrid Cloud Technology Leader, driving AI innovation and workload optimization for enterprises. Arnold holds an MBA in IT management and electrical engineering degree and completed IBM's Client Executive Program at Harvard. He is an expert in solution design across x86, IBM Power, IBM Z, and cloud platforms, and is in 2022 Lou V. Gerstner Jr. Award he received for hybrid cloud solutions with the Government of Canada. We'll take the opportunity now to dive into the Migration Masterclass, and we'll start it over with Bruce, and I'll hand it over to Bruce to start his keynote from this point forward. Thank you, and look forward to the session.
Hi, I'm Bruce Turgeon. Thank you for the introduction. We launched the Power 11 in July 8th of 2025. I was there live, and you might have also catched it virtually. So relatively new, but a good time to be thinking about moving to Power 11. Power 11, we often think, I think what they show is often a 32-inch rack with big server in it, but it starts as small as a single 2U, two socket server, which is very powerful and functional. Um, I did a little question to AI to see what they say about Power 11, and it was fairly accurate. Really, Power 11 is designed for the AI era, for hybrid cloud environments, and it comes with enhanced reliability and built-in AI. It has advanced security features like quantum safe, energy saving modes, improved resource management. So we're going to hit on a lot of these points during this session. What it didn't have was the performance gain. So actually, the register mentioned this: 55% faster cores than Power 9. So all in all, it's a big move forward with Power 11. So this is the Power 11 server lineup before we get started into migrating to these servers, because we need to understand what target we're going to choose. So the server I showed earlier was the S1122, the one on the left. The nomenclature of that is S is for scale out, 11's for Power 11, and then it's a two socket 2U server. So that's the twos. And then if you move over to the next server, it's a four socket, sorry, it's a two socket 4U server. And then the next two are E for enterprise. So these are our higher end systems. So you'll have seen the E1180 in a large rack, and the 50 and the 80 don't stand for U's or cores. It's just a naming convention. And also be aware that all these Power servers are also available in the cloud. They're called Power VS, Power Virtual Server. So you can run this in the cloud. You can also run a hybrid cloud solution. And I just want to cover the roadmap here because this is significant too in your migration planning. So we're at Power 11 today, and I went back several generations here. Power 9 is coming to end of support for some of the servers at the beginning of next year. The enterprise servers end of support is much later, but still, we got to start considering moving from P9 to P11. And this is really the best window to start thinking about that. And if you're on Power 8, that's already end of support, and you should be looking at moving that forward. So let's just talk about IBM's release of chips. Generally, we do a new architecture every 4 years. And you can see that there's a future that's already in development. So we can expect approximately 4 years from now. It could be a little bit longer because it's a real architecture change. It's fairly significant. But yeah, you got pretty much a 4 year gap between each. So Power 9 was 2017. And what you want to do is optimize when you're migrating the value of the system that you had um, to when you move forward. And first, I want to talk about features that were added. So the Power Virtual Server was added for Power 8, and it continues forward all the generations. So we had Power 8 in the cloud, Power 9, Power 10, Power 11, and we do keep some down level servers in the cloud if you want to run on those. And then with the Power 9, one of the significant features that came there was Power Enterprise Pools 2.0. There was Enterprise Pools before that, which was technically 1.0, but the functionality changed a bit, and PEP 2.0 is what we call it, is very functional, very useful tool. And I'm going to get into that more later. And again, that's carried forward and is available in Power 11 as well. And then Power 10 was a huge shift, I think, because we got to in-core AI acceleration. So AI is built into the chip architecture, and also The system is quantum safe encrypted. So data at rest and in flight is all encrypted. So much more uh, safe for your data. And, I think Power 10 is now the clip level that you need to make sure all your systems are at least there. And again, these features have carried forward to Power 11. And Power 11 is now 6 nines of availability, whereas Power 10 was 5 nines. So there's been a focus on increasing the availability of these systems. And really, we talk about zero downtime now because of automation that we built into the server as well, that we can avoid outages completely. Uh, the other aspect that we're bringing to Power 11 is the Spire accelerator, which we'll talk quite a bit more later in this session, but that adds to our already built-in AI and is going to be, key in this AI age. So just looking at this again to optimize your investment of the server, your total cost of ownership. If you're moving from P9 to P11, you're getting 8+ years out of that server that you can spread your total cost of ownership over. The guideline for x86 is anywhere between 3 and 5 years. So you're refreshing power less often, so you're getting more value there out of it. And definitely, I've added in Power 7 at the very bottom, which came out in 2010. So I mean, if you're going from Power 7, you got 15 years out of your infrastructure. But the issue there is you're unsupported and want to make sure you're keeping at a server level that's still supported. You can also upgrade each generation, and I would suggest doing leasing where you have a residual value, and then you could roll to each technology as it comes out. But this is a unique year because there's not as much differences between Power 10 and Power 11 as there was other generations. You can actually upgrade from Power 10 to Power 11 and keep your serial number. And that's for the enterprise class servers. So the E1050 and the E1080, you could move those forward to Power 11 chips and keep your serial number. So something to consider. So I also looking at the performance gain per core for each generation of chip, which is something to think about when you got your applications running. What IBM does is they increase the per core performance on every generation, whereas x86 first looks at increasing the number of cores per socket. We do cores per socket second, but per core performance always has to go up. So you're always gaining, if you have per core software licensing, you're always gaining extra performance as you move forward. So I took an S822 single core going to an S922, you're gaining 13% per core. This is relative performance. So going from S922 to an S1022, you're gaining 16%. And going from S1022 to an S1122, you're gaining 11%. But rules of thumb, like this is like a per core on a small scale server, but like on the enterprise servers, when we went from P8 to P10, it was a 2-for-1 replacement. So two Power 8 cores could be replaced with one Power 10 core. So there are other considerations. It really depends on what you have and what your targets are. And I'm going to get into that in a minute, but we need to calculate, what gain you're seeing based on the servers selected. Yeah, and if you go from P9 to the P11 on the same server, you're getting a 29% gain. So we're up for question number 1 to the audience. So are you looking to move to a Power 11 server anytime soon? Let us know. You looking in 6 months or uh, you're still evaluating, you don't have plans? The correct answer is the top one, by the way. Did everybody get a chance to respond to that?
We'll just give it a few more seconds, and then you can respond, and then the poll question will disappear from the screen.
Okay, so let's talk a little bit more about this master migration plan. So I laid out the key points here, but at the end, I'm going to come back to this and talk more specifics on each one. But to me, it's a five-step plan. A lot of people, when they think of migration, they're thinking of step five, where they're actually implementing it. How are we going to move the workload over to the other box, etc. Where we, as system matter experts, get pulled in is usually step four, which is help us size the server. What do we need to purchase? And that's often late in the game because we didn't have the information that should have been in steps one, two, and three that led into it. So I'm going to start with four, server sizing, but I'm going to come back to the other points and we'll summarize this at the end. So sizing methodology is the first thing to consider. So I've broken this out into four types of sizing. To me, the number one is the typical sizing. So it's based on relative performance. So for IBM Power systems, we have what we call R perf, which is the relative performance. But we also have CPW, which is the relative performance metric that we use for IBM I. So it varies on what OS you're using. So if you're uh, running AX, it would be the relative performance, and often we fall to that as a general system consideration. So we would take the relative performance of the server you have, so say like a Power 8 or a Power 9 server, and then match that relative performance in a Power 11 server. So sometimes you may be going even from an enterprise server to a scale out server because that meets your capacity requirements. So that really has a lot of fluff built into it because you'll end up getting a lot more performance than you need in the Power 11 server, which is great if you're anticipating lots of growth. But number two is, a little bit better in that we look at the number of cores and we just match the number of cores in the system. So this one also gives you growth, but it's really good for IBM I. IBM I is a cost premium per core for that operating system. And you don't really get any credit for reducing the number of cores. So it's generally better to keep moving your licensing forward and keep the same number of IBM I cores. So there we just match cores in the box. Number three is getting into more cost savings, especially for AX, is looking at the relative performance that's on the assigned capacity. So when you look at a server, often there's cores in memory that haven't been assigned to any of the applications. So they're dark capacity. You don't need to include that in the new server sizing. So just size for what's been allocated because you've been using that for 8 years and it's been good. And then number four is more analyzing, and that's looking at your actual utilization. So we would be looking at what your average utilization is for the whole server and per application over a period of time, and sizing the server based on what you actually need. If you're anticipating growth, that could be calculated in. So we could uplift the sizing based on your growth plans. So here's a subset of the RPerf numbers, and there's a CPU, there's a CPW list as well. And I didn't include the E1080, E1180, but uh, so this just gives you, I'm just going to give an example out of this. And then based on your specific environment, we would pull up the proper relative performance numbers for the server you have, plus the targets that we want to go to and do similar calculations. So if you look at this, we take an S10 22 32 core server, has 728.3 relative performance. If we went to a 32 core S1122, so same class of server, same number of cores, we're seeing that 11% gain that I mentioned on the initial slide. So let's look at some other ones here. If I looked at a maxed out S1022 with 40 cores and went to a maxed out S1122, you'll see that it has 60 cores. So we're getting more cores per socket, but also more performance per core. So the growth there ends up being 49%. So if you're already maxing out an S1022 and you need growth, you could get growth in the same class server using Power 11. So let's look back at S922. A typical configuration of the S922 was the 16 core server. The 10 and 11 core were a little bit more costly. So the best price performer was the 16 core and met a lot of people's workload requirements for a scale out server. So if we went from that to a fairly common S1022, which was the 24 core, because again, the higher core counts cost a little bit more. The gain is still 75%. So you're going from 16 cores to 24 cores plus the per core performance gain. So if we move that forward to what I think would be a popular S1122, which would be the 32 core version, you're getting a gain of 47% from Power 10 to Power 11. So if you're moving from that P9 S922 to an S1122, pretty significant gain in overall server performance plus per core performance. So one of the key things is collecting server stats. So we need information on your servers ahead of time before we get to the sizing because this data needs to be collected over time. So HMC scanner is one of the most common ones that people use. I would just remind people to enable the HMC performance data collection. So we want to be collecting that at least a year in advance. So this is a great tool. It gives you a bunch of spreadsheets. It includes a list of all the logical partitions, what OS levels they're at, the compatibility modes, which is important. So you could have a Power 9 server, but you're running the AX operating system in Power 8 compatibility mode. So these are other things to consider when we're moving forward. Um, it also gives you assigned cores on another tab to each of the VMs, and it gives you assigned memory as well. So these are all, you know, key factors when we're figuring out the sizing of the overall server. And it also, let me just step back there. If you're doing the performance data collection, you can get usage summaries and graphs for average day, average week, average month. So those are useful too. So LPAR2RRD is a really good third-party application for monitoring system usage. And it can not just be used for power, but you can use it on other environments, and it can also be used for application monitoring. So it gives you a whole bunch of utilization data and graphs. So this is just some examples here. So each virtual machine is shown as a different color on there, and then the names of them are included below with their average and max. And you can grab a lot of other utilization information out of that. So um, the next one is the NMON monitor or the Nigel monitor, and it uses several other tools like the analyzer that format the information that's collected. This is my favorite tool. Down at the bottom of the screen there, you can see there's several tabs. It's just there's almost an infinite number of tabs, and it gives you absolutely everything you'd ever want to know about the server and how it's performing. So it does give you the detailed utilization data, and you can show it on graphs. There's an example of a complex graph there. So now I'm going to turn it over to Arnold Ness for Power 11 advantages, because it's not just about moving from these older servers to Power 11, but there's lots of other features and functions that are added to the Power 11 product that you need to be aware of, and what the advantages that they bring to your environment. So we got to think about not just moving forward, but how do we improve your environment? How do we get more out of your environment? And Arnold's also going to remind you why you chose Power versus x86 when you're comparing. So turn it over to Arnold.
Great. Thanks, Bruce. And yeah, essentially, Power is one of the best kept secrets out there in the industry. So we typically run, twice the amount of workload, 2.5 to 4 times the amount of workload per core versus x86. But I'll get into that, as we continue to go through a couple of the charts. From an industry perspective, x86 is 47 years old today. So, we're starting to see kind of the upper limits of that architecture with respect to performance improvements over time. And that's why versus the Power architecture, which is scale up, the x86 architecture is scale out. So you're seeing 192 core AMD, and they're looking to continue to increase the amount of cores that you're seeing. From a software perspective, software and support are 85 to 90% of the total cost of ownership of an IT solution over 5 years. So as an organization or an enterprise, if you're looking to reduce your cost, you'll have a far greater probability of reducing your cost if you can reduce the number of software licenses that you need versus going with a less expensive x86 server. So for example, and I've got a couple examples coming up, but if you can save 50% of your software, that's going to be significantly greater value to you than reducing the cost of the hardware that it runs on. We're also looking for 1 billion new apps expected by 2028, and those will be from an AI perspective. And with AI, there's two components. There's model generation, which we're recommending that you use in the cloud, and with the GPUs that are in the cloud. From an IBM cloud perspective, we've got Intel, AMD, and NVIDIA GPUs in our cloud, and we support the creation of models there. And then take that model, export it to a Power platform, and then be able to leverage the matrix math accelerators that are built into Power to be able to support inferencing at a significantly lower cost, lower energy cost, and lower footprint versus x86 and GPU. All right. So this is an example of benchmark looking at the total cost of ownership from x86 versus Power. So this is a 1022 running Web3 application server with OpenShift on top of OpenShift on top of the platform. And you see over 3 years, it's 45% lower from a cost of ownership versus x86. And in fact, if you look at the 5 year, because the next 2 years will just be support from a software perspective, that will be over 50% savings. Another benchmark example. This is Cloud Vector Data running on Red Hat OpenShift, and you see that you can run that for the same workload for 1.5 million on Power, and in an x86 world that would be 3.5 million. So for an extra $2 million, you can buy a bunch of additional software licenses, but you're not getting any additional business value. Sorry. Same from a comparison, we've got similar performance comparisons and advantages from a Power core versus the x86 core. And this is true with DB2, Red Hat Enterprise, Linux, MongoDB, Postgres, SQL that runs on top of the platform. So when you're looking at large workloads, large database workloads, SAP, you've got the ability to save substantially by running those on a Power platform versus running on an x86 environment. This is just an SAP benchmark. I won't spend too much time on it. We'll share all of this. So from a Power 11, what's new from a Power 11 is we've increased the reliability and availability of the platform to 6 nines, which is less than 32 seconds of unplanned downtime per year. We're also working on the planned downtime. So we've got hot fixes and that can be applied, and we're working on leveraging AI from an operations perspective to help you be able to run and manage the environment. And then finally, we are working with the storage team, and we've got a new solution called Power Cyber Vault, and that will detect a ransomware attack in less than a minute, and then automatically roll back to previous backups. They'll take the previous backups, we'll load them into a sandbox, they'll test them to make sure that there's no ransomware there. And once they've been able to back up to one that has got no issues, they'll be able to restore it using the automated tools to allow you to recover much faster than the traditional method. So from an overall Power 11 perspective, so as Bruce was saying, it's a 7 nanometer chip. So if we look at the bottom, of the stack, so we've improved it from an energy efficiency and a performance perspective. They're both 7 nanometers. They're both being designed and manufactured by Samsung for us. On top of that, we've layered, DDR5 memory along with our OMI interfaces. So we've got, 3 times the memory bandwidth versus DDR4 and a Power 10. So for in-memory databases like Oracle, SAP, these are tremendous, performance improvements for them. Stepping up a bit, we've got improved energy management, and we're also quantum safe. So at the platform level, we've got Trusted Boot, which is using NIST-approved quantum safe algorithm. And then as you layer on top the operating system, the license program management applications, those are all checked, and they use quantum safe algorithms to ensure the security of the platform. And Power SC is a tool that's available, and Power SC will scan your environment and look for what types of encryption algorithms you're using, where you're using it, and whether it's weak or obsolete, so that you can then look to migrate from the existing encryption algorithms to the future quantum safe algorithm. And then finally, the Matrix Math Accelerator. We introduced Matrix Math Accelerators, 4 Matrix Math Accelerators per core with Power 10. We brought that forward with Power 11. The Matrix Math Accelerators have the ability to handle a little over 20 trillion operations per second per core. So, Bruce was saying, that, a 42 core, would be, an example server capacity. So 42 cores times 20 trillion operations per second. That gives you the amount of matrix of machine learning and AI inferencing that can be supported, on the platform itself. And then we've also introduced a new Spire accelerator. The Spire accelerator has been developed and designed by IBM Research to be able to provide, significantly lower energy utilization for inferencing. And this is available for both the IBM mainframe and the Power systems. It'll be generally available December 12th. Just a quick picture of the lineup of Power 10s. As Bruce said, scale out, scale up. Same thing from a Power 11. I've included the Edge device, which will be coming in 2026. So kind of a one socket system that will expand the range, down to Edge devices. So the Power 10, the Power 11 processor looks like this. It's got 4 matrix math accelerators per core. It's using the OMI memory interface. This leads to significantly larger memory bandwidth. So both the mainframe and the IBM Power system uses what's called buffer technology. Oops, not sure what happened there. We'll try to get back. So as you can see, we support, so you get the x86 up in the left-hand corner, which supports only a limited number of memory connections, and those are dedicated memory connections. So when you go from DDR4 to DDR5, you have to replace the processor plus the memory. And when you go from DDR5, which is available now, to DDR6 that they're working on, again, you'll have to replace that technology. From an IBM Power perspective, we have already gone from DDR4 to DDR5 using this buffer interconnection. It supports 4 times the amount of bandwidth with superior reliability. And if you go into the marketplace and you query DDR5 and x86 or AMD, you'll find that they're having some significant issues with populating it, driving it, and being able to run it at speed. We've had no issues from a power perspective with DDR5, and that's allowed us to go from 400 gigs per socket to 1,200 gigabits per socket. So 3 times the bandwidth improvement. And again, that's great for large memory databases. And I apologize, I've got to speed up a bit. This just talks about Power Virtual Server. So Power Virtual Server is a combination of IBM servers, storage, network capabilities. We've pre-built it into a pod. We've tested it. It's available in our cloud, or it's available for you on-prem. So if you're looking to build a sovereign private cloud, we have the ability to help you build that on-prem for you to enhance the sovereignty and the security of your environments. IBM uses Power Virtual Server to support our transition from SAP ECC and DB2 on the mainframe to RISE with SAP on Power VS. So we did this in an 18-month period. We have moved to live production in over 175 countries with over 150,000 users, and that resulted in a 30% reduction in our overall operational costs versus running SAP ECC DB2 in the mainframe. We selected Power VS because of the 6 nines availability and the far more reliable and robust infrastructure. So Intel discontinued their persistent memory several years ago. Our persistent memory structure allows you to restart HANA partitions 17 times faster. And from a per core perspective, we're 2.5 times the core performance with a Power Core versus x86, which leads to lower total cost of ownership. This is essentially it's the Swiss equivalent of the Government of Canada Shared Services, and they went from 64 x86 servers to 5 Power servers. They were able to reduce delivery of SAP HANA instances by 95%. And they've improved their cost structure as well as their availability as part of this server consolidation. So quantum safe. So we've got another poll question here.
We'll keep the question up for about 30 seconds and then we'll take it down. Feel free to answer the question.
And while you're answering, I'll just talk about the slide in behind. So the government of Canada has come out and mandated that the critical departments at the government of Canada have got to come up with a plan by April 1st of next year. And then by April 1st of 2027, they've got to identify the specific components of being able to migrate to quantum safe cryptography. And they're looking to have them transitioned by December 31st, 2031. Now that's in Canada. In the United States, the NSA has mandated December 30th of 2030. So, what we're seeing is the governments of most countries around the world are mandating this migration to quantum safe algorithms. And what's not far behind is finance, insurance, and the health organizations. So if this isn't already mandated, it will probably be mandated fairly soon. And this is because of the rapid development of quantum technology that will crack all of the existing algorithms that are in the marketplace today. So from a Power11 perspective, as I said, we've built it into the platform. It's available today. So if you're looking to move to a quantum safe infrastructure, migrating to Power11 would be the quickest way to get that done. And then, from a risk assessment and a remediation perspective, we have what's called Power SC that's available that will scan the software and identify what encryption algorithms you're using where. So from an AI perspective, just jump to the next polling question.
So we'll keep this question up for the next 30 seconds, but it's, are you going to do large amount of AI inferencing workload on-prem? Yes or no?
And while you're answering that, I wanted to highlight that one of the things that IBM has done globally is we call ourselves Client Zero. So we have implemented Red Hat OpenShift to create a common CI/CD development pipeline across all of our different organizations globally. This has allowed us to move from having operations in over 175 countries to 2 public clouds and 2 private clouds that support our operations. We've taken $3.5 billion out of our cost of delivery as part of this migration, and this has allowed us to rapidly speed up delivery of service and capabilities. So from an AI perspective, we're leveraging Red Hat OpenShift as that common middleware layer that allows us to have IBM infrastructure on-prem in our private clouds, public clouds, both Azure, AWS, IBM, and others. And then we've got enterprise and edge infrastructure that supports Red Hat OpenShift. And then you've got a bunch of different application layers on top that will leverage that. From an AI perspective, this is the Spire adapter. So the Spire adapters supports greater than 360 trillion operations per adapter. And from a Power11 perspective, you would install an IO drawer. There would be 8 adapters per IO drawer. So that would give you about 2,800 trillion operations per second per IO drawer in a 600-watt footprint from an energy perspective. So this is a dramatic improvement in price, performance, and energy for enterprise clients. This would allow you to deploy most AI from an enterprise perspective, on-prem, without GPU. So Power 9, was the initial foundation, and we had GPUs attached externally. With Power 10, we shifted to in-core matrix math accelerators that support that. And with Power 11, in addition to the in-core matrix math accelerators, we've added the external Spire adapters. That will allow us to support, RPG code assistance, for example, in the IBM I environment, but also digital assistants and chatbots that can work with you. So, are you looking at real-time fraud detection? Are you looking at real-time, interaction with clients, from a telephone perspective? So that will allow you to deliver those types of capabilities in an on-prem basis. We've also been working to turn this and transform this into turnkey AI. So we've created a bunch of capabilities. So there'll be a catalog that comes along with it. We just recently announced Red Hat.ai as being supported on the Power platform. And we also support WatsonX.data, the IBM Knowledge Catalog, Data Stage that are part of the Cloud Pak for Data solutions. So that along with these pre-built AI services, we've got Ansible scripts that will create kind of a one-click implementation to then start delivering AI services, as opposed to you designing and figuring them out yourself. So we've got a bunch of different examples. This will be filling out over time. We will be starting from a GA perspective in early December, and then we'll continue to expand this with clients on a global basis. This allows you to, create your models in the cloud. So AWS, Azure, OpenAI as an example, and then migrate those onto the Power platform, and then deliver them from an inferencing perspective with Power11 Inspire from a launch perspective. This is just another example. This is a hospital over in Thailand, and what they do is they create the AI models, on the cloud using NVIDIA GPUs. So, and they retrain it every 3 months. They migrate it to, in this case, Power 10, and they run it on-prem from an inferencing perspective. And then they capture a bunch of information, they feed that back, and then they update their models on a quarterly basis. We've got a bunch of different business partners that are coming in this space, Equitas, Finacle, Wallaroo, as well as I was saying, WatsonX.data, Data Stage, IBM Knowledge Catalog. So we've got both the IBM components as well as the open systems and open source solution. So from this allows you to deploy AI on-prem, or using Power Virtual Server, you can deploy it in the cloud with us as well. So then from a case study perspective, Wallaroo had been building AI on x86 for many years. They'd been working with organizations like the U.S. Military. They're able to make a couple changes to a couple of lines of code, and then deploy that on Power. And by doing that, they've seen an 80% reduction in infrastructure costs and a 12.5 times speed up from a processing perspective, versus running these in an x86 environment. And same thing with Equitas. Equitas will turn every camera into a powered surveillance system. So this gives you a low-cost ability to add video surveillance, tracking, and a bunch of additional capabilities that can be augmented fairly easily and delivered from a Power perspective. And then finally, but not the least, Oracle. So 22% of Oracle's database globally run on Power. And they do that because we significantly reduce the number of Oracle licenses. We have what's called hard partitioning versus x86. So if you used a 192 core AMD processor, you'd have to buy 192 Oracle licenses to run that Oracle workload. On Power, you can segment and create a partition, and you can allocate 6 cores to that partition, and you'd have to pay for 6 licenses. So you can dramatically reduce your cost from an Oracle perspective by deploying Oracle on Power and leveraging, the scale up processor capabilities. This is just an example of a client that was running on HP Superdome. They had 288 cores. They were able to move that to an E1050, which basically ran 48 cores, saving them 2.6 million. So, dramatic savings, again, as I was saying at the beginning, by leveraging Power versus leveraging x86. And with that, I'll turn it back to Bruce.
Thank you very much. So I'll wrap this up quickly, and we'll get to your questions. So back to the migration plan, I'm going to cover number 3, the architectural considerations. So key aspects to consider for optimizing total cost of ownership from an architecture point of view is the live partition mobility, shared processor pools, resource groups, enterprise pools, and CapEx versus OpEx, which I'm going to get into quickly here. First off, for live partition mobility, you need to be able to virtualize each of your virtual machines. So that's through the Power VM and the virtual I/O servers. So I would hope that everybody out there is fully virtualized today. They're not assigning resources directly to the operating system. But that gives you the flexibility to move your applications live while they're running from one server to another. And then not necessarily running them live. It might be safer to do it off hours, but it has that ability. So at least you can move it over and test it. Virtual processor pools. So you can create these sub-shared processor pools, and you can collect together similar applications like Oracle or DB2 could be in their own shared pools. So you could have multiple partitions that were all using Oracle, say, but as a total shared pool, it has like maybe 8 cores. But if you added up each of the partitions, it would add up to like 16 cores. But you're only paying for the 8-core license, and that 8-core license is basically shared between all those applications. And then a new way of doing it, in addition to that, is the resource groups. So this kind of layers on top of the shared processor pools, but it lets you group similar applications together so they can be licensed together. And the result is it gives them better performance, better utilization of that shared pool. And then enterprise pools 2.0. So I want to explain a little bit how this can be an advantage to you. Up to 50% lower initial base capacity, pay for use by the minute. So it's like a cloud. You can reduce your costs, and you can get history monitoring of the data, etc. So this is the typical model where you activate enough cores for your workload, so you're not paying any extra like you would cloud. But it's all metered in pool 1. So those resources can be used across any of the 3 systems, but you can see combined, they never use more than the capacity that you've purchased. Where this works really well is in a DR scenario. So if there was a DR event, those metered availability would become immediately available on the DR side. There's no transferring required. It would have access to all that core activation because it's not being used in production. And so it could go to system D, and you could be running without paying for those extra cores in DR or system D on a regular basis. The other thing to look at is you could go minimum and be charged by the minute by how much you're using. So very much a cloud model. So that's kind of the CapEx versus OpEx. So you could shift your environment into an OpEx environment and just pay for what you use. The number one consideration for your migration planning is the operating system levels that you're going to, and making sure that your application levels are supported on that version of operating system. So this gets into that point number 1 on the migration chart, is that on a yearly basis, you should be checking all your levels and make sure that you're keeping your applications, your OS, your firmware, etc., all up to date, right? So if your systems are all up to date, it's easy to do the migration. But after 8 years, and if you haven't done many updates on your system, there's more work to be done, and this needs to be done in advance. So it's the first thing you look at is how am I going to get my applications up to the level that I need them. And it's good overall because you want to be on supported hardware, supported operating system, and supported application. And then don't forget you need HMC version 11. So this is all out of the red books. You can look these up as to what levels you need to get to. And then the total cost of acquisition, don't forget that you saw this chart earlier, but don't forget like that red bar at the bottom, the power system includes a lot of things that x86 doesn't. So, leading edge hardware-based virtualization, quantum safe encryption, built-in security from the firmware level up, integrated AI, and zero downtime. So, you're getting a lot of extra value out of that, even
So
that red
Bruce,
box
just
at the
to,
bottom.
sorry to interject, Bruce, just a time check with 3 minutes left and we have
Yeah,
to cover some
got it.
Q&A.
Yeah, almost done. Total cost of ownership. So these are all the breakout of things that you consider for cost of ownership. The important one here is software licensing. So server sizing and resource groups are critical to look at because software is over 80% of the the total cost of ownership. And then there's a lot of value in our per core performance compared to x86. So you get like four times, so four x86 servers to one power server, plus you get performance efficiencies, which is priceless. And then this is the migration slide summary at the end. So one, maintain best practices. So engage us early, engage us at stage one. Don't wait for stage four to bring us in. Stage two is to make sure you're collecting the data you need and practice with it. So we can look at that in advance and make sure we're collecting what we want. Architectural considerations, all those things I talked about, should be looked at 6 months or more in advance. Then there's server sizing, and then number five, which we didn't get into, was the last bit is how are we going to do it? So let's go to questions.
So thank you for that, Bruce. We'll just open up the Q&A. There was a couple of good questions. I'll start with the first one. With respect to, you were saying Power 9 is out of support early 2026. Can you confirm and elaborate and what we need to do to our Power 9 servers now? And there's a follow-up questions to that, is that can we extend the extended support for Power 9 after early 2026?
Yeah, so my comment there was some Power 9 servers are going to be withdrawn from support in January of 2026. But that's not all Power 9 servers, especially if you have the enterprise, like the 950. Uh, the end of support is a couple more years away. But yeah, you can always get extended support. But if it's been a withdrawn from support product, um, you can't get like you may not always be able to get the parts. So if this server has a problem, there may not be parts that would work to replace it. But you
Yeah,
can
so
get ongoing support.
so support works on best efforts basis
Yeah.
after the end of support date. But the more critical issue is related to software patches. So in this world of kind of heightened cybersecurity, at end of support, there's no additional patches that are created, for the platform. So you're really, running in, an unsupported type of an environment. And what Bruce is suggesting is you start to take a look at migrating now, either to Power 10 or Power 11. Power 11 will give you a much longer runway. Um, some clients, I've got some clients that are upgrading and purchasing, Power 10s because you can put Power 10, 9 and 10 in a pool at the same time, and you can migrate your workload from 9 to 10, and then you can MES upgrade the 1050s and the 1080s to 1150 and 1180s down the road once you've got everything in the pool, at the Power 10 level.
Perfect. We want everybody to be on Power 11 so they get the best of the best. But next question, are there any parameters other than SMT to gauge relative performance of the servers?
Yeah. So the relative performance numbers, I was using SMT4. That's symmetric multi-threading. That's kind of a more conservative number and more typical of what people are running. But if you know you're running SMT8, then definitely we would use the RPerf associated with the SMT8. The other things that would affect relative performance would be things like the processor mode. So if you were on Power 9, but you were running in P8 processor mode, we don't publish our perf numbers for that, but we do have kind of rules of thumb based on the different architectures as to how much that would affect the performance potentially. But yeah, the R perf we provide for SMT4 and SMT8. Everything else we have to kind of do by rule of thumb. But all those
Perfect.
numbers are available on the internet.
Thanks for that, Bruce. And just we'll take one last question before we close up. But can we find QPI numbers on the IBM website?
Arnold, do you have that one?
I was going to say we typically use the RPerf to be able to compare within the platform as opposed to QPI. There are some QPI numbers that are there, but the standard benchmarks that IBM uses are the RPerf to compare across the generations and across the families. The other thing I wanted to mention is SMT4, SMT8, that stands for the number of threads that you're running. Power can run up to 8 threads per core, whereas in an Intel architecture, you can support only 2. And in a secure environment, they recommend that you turn hyperthreading off, so you're just running with a single thread in x86. And if you're running VMware, for example, they recommend that you turn hyperthreading off. So from a throughput and a performance perspective, we can do up to 8 things per clock cycle where they're doing 1 in that same clock cycle.
Okay, well, thank you. Thank you, Arnold. Thank you, Bruce. Thank you to all the attendees who took their time out of their day to attend our event. We do have a screen up in front of you. If there are any inquiries or any other further questions, you can email us at info@fahmpartners.com. Otherwise, we do have your information, and we will be sending you a courtesy message along with if you require the webinar. We will reach out to you with that information. But look forward to talking to you and helping you through your Power 11 journey. Thank you again, and have a great day.
Thanks,
Thank
everyone.
you.
Sure.